Imagine a world so relentlessly hostile, a place where the very air seems to conspire against technology. It doesn't just damage visiting spacecraft, it utterly destroys them in a matter of minutes, sometimes even seconds. This is Venus, often called Earth's twin, a planet of similar size and composition. But instead of being a sister planet, it's a graveyard for our ambitions, a stark reminder of nature's power. We dream of Mars, envisioning colonies and exploration. But Venus, shrouded in its toxic atmosphere, is the true test of our technological prowess and our understanding of planetary science. Its surface is more punishing, a landscape forged in fire and brimstone. It presents challenges far exceeding any place we've encountered on Earth or even the relatively more forgiving environment of Mars. Every probe we send to Venus faces a desperate race against time, a battle against overwhelming odds. It's battling heat that can melt lead, pressure that would crush a submarine, and acid that dissolves metal like sugar in water. Venus doesn't just challenge our technology with individual obstacles, it relentlessly crushes it under the weight of its extreme conditions. This often happens within mere moments of arrival, a testament to the planet's unforgiving nature. The story of Venus exploration is not one of triumph, but rather is one of fleeting, hard-won glimpses of the surface, snatched in the face of almost certain destruction. These glimpses are all we get before our machines are inevitably silenced by the planet's wrath. It's a planetary furnace, a crucible where technology is tested to its breaking point. It serves as a cautionary tale, a stark warning of what happens when a world's climate spins irrevocably out of control, leading to a runaway greenhouse effect. Exploring Venus pushes our engineering to the absolute limit, demanding innovation at every turn. It's forcing us to innovate and develop materials and technologies we never thought possible, just to survive a few fleeting minutes on its scorching surface. The brief moments our probes have managed to survive there, transmitting data back to Earth, are among the most hard-fought and celebrated achievements in the history of space exploration. They represent a triumph of human ingenuity against seemingly insurmountable odds in space exploration. Venus is a stark reminder. The universe is far more dangerous, complex, and diverse than we often imagine, filled with environments that defy our expectations. It's a humbling lesson in the face of the vast cosmos and the unknown dangers that await us. The surface of Venus is a truly hellish environment, a scorching 465 degrees Celsius. That's hot enough to make you think twice about even approaching the planet. It's hot enough to melt lead, turning solid metal into a flowing liquid. Imagine the implications for any machinery we send there. Imagine dropping a sophisticated robot into a roaring industrial furnace and expecting it to not only survive but also to function perfectly. That's essentially what we ask of our spacecraft when we send them to Venus. They have to endure conditions that would destroy almost anything we create. Venus's thick, dense atmosphere, composed primarily of carbon dioxide, acts like a blanket, trapping heat with incredible efficiency. This creates a runaway greenhouse effect, an extreme example of what can happen when a planet's atmosphere becomes overloaded with greenhouse gases. The result is a planet-wide oven, a landscape of searing heat and intense pressure that never lets up. There's absolutely no relief from this heat. There are no cool poles to escape to, no temperature gradient offering a respite, and there's no nighttime drop in temperature, no cyclical cooling to offer a temporary reprieve. It's just relentless, uniform heat, baking the entire planet equally day in and day out. But the extreme heat is only half the battle, because the pressure on Venus is just as brutal. The atmospheric pressure is over 90 times that of Earth's, a crushing weight bearing down on everything. It's like being a kilometer underwater in Earth's oceans, where the pressure is immense. Our landers must be both deep-sea submersibles, capable of withstanding incredible pressure, and blast furnaces, able to endure searing heat. They must be built to resist both crushing and melting at once, a monumental engineering challenge. Every single component, from the smallest circuit to the largest panel, must be completely reimagined and redesigned. All of this is necessary to survive even a short time in this planetary pressure cooker. Designing a Venus rover that can operate for any useful length of time is truly an engineering nightmare of the highest order. The challenges are far, far beyond those we face when sending rovers to Mars, a world that now seems almost hospitable by comparison. On Venus, survival is measured not in days or hours, but in mere minutes. It's certainly not measured in years, like some of our successful Mars missions. As if heat and pressure weren't enough, Venus's clouds are made of sulfuric acid. Descending probes are bombarded by corrosive droplets, their surfaces dissolving before they even reach the ground. The Soviet Venera missions had to armor their landers against this chemical onslaught. Even on the surface, the air remains a toxic reactive soup, slowly eating away at every exposed instrument. Visibility is poor, the sky is a dim, oppressive orange-yellow, and the dense air scatters light in all directions. There's no water. Venus is bone-dry, its oceans long gone. These hellish conditions make life impossible and human exploration a distant dream. Venus's acid clouds are a final, relentless assault on any machine we send. Mars rovers like Curiosity and Perseverance, technological marvels that they are, operate for years, traversing the rusty landscape and sending back stunning images and invaluable data. These rovers are our eyes and ears on another world, tirelessly exploring and analyzing. On Venus, the record is a mere 127 minutes, the fleeting lifespan of Venera 13's brief window before succumbing to the planet's harsh conditions and being ultimately destroyed. Years of meticulous planning, millions of miles traveled through the vast expanse of space, all culminating in a precious 2-hour glimpse of a world shrouded in mystery and danger. Venus, Earth, and Mars, once cosmic siblings, started their planetary journeys under similar conditions. But Venus's unfortunate proximity to the Sun triggered a catastrophic runaway greenhouse effect, altering its destiny forever. Its once abundant oceans boiled away into the atmosphere, trapping unimaginable amounts of heat and creating a planet-wide inferno, a landscape of scorching temperatures and toxic gases. Mars, in contrast, lost its atmosphere to the ravages of space and froze into a desolate, cold desert, while Venus became a world consumed by present fury, a testament to unchecked planetary evolution. Exploring Mars is akin to archaeology, carefully piecing together fragments of a lost past, uncovering secrets buried beneath layers of Martian dust. Exploring Venus, however, is more like combat, a constant struggle to survive a relentless assault of heat, pressure, and corrosive atmosphere, just long enough to gather vital data and report back before succumbing to the planet's overwhelming hostility. These twin planets, once so similar, took dramatically different paths, and Venus is a stark reminder of how a planet can transform into a true hell world, a cautionary tale written across its scorching surface. Its story serves as a chilling warning of how quickly and irrevocably a planet's fate can change, a lesson we must heed as we contemplate our own future. Venus attacks our machines with heat, pressure, and acid, each a mission killer on its own. Together, they make Venus the ultimate test for planetary science. Unlike Mars's cold vacuum, Venus is an active, aggressive destroyer of technology. The brief lives of Venus landers have given us precious, hard-won data, a glimpse of flat rocks and a gloomy orange sky. These missions are triumphs of ingenuity, not failures. They inspire us to build tougher, smarter machines, maybe even clockwork rovers or armored landers for the next attempt. Venus challenges us to be bolder and more creative in our quest to explore the cosmos. Keep looking up. There's always another adventure waiting in the universe.